Hello friends, so today we'll be dealing with the Maddox rod, yet again a very important and a volatile topic of ophthalmology. So Maddox rod, let us solve a question related to Maddox rod and try to clear the concepts of the Maddox rod. In a patient of left eye exophoria, exo means the outward squint, that is divergent squint, and phoria means the latent squint. Now Maddox rod is placed in front of the right eye. Now this is other important thing. You should always see in which eye, in front of which eye we are keeping the Maddox rod. With its axis horizontal, and patient will see bright spot in relation to the red line. Okay. Now let us try to clear the concepts of the Maddox rod. What is actually Maddox rod? Maddox rod means that we have got so many cylinders that are placed parallelly hacked over one over the other. Okay. Now because we have so many cylinders, there is a property of the Maddox rod that it will convert a point source of light into a line. Now this line will be red in color because we have got the cylinders which are red, and the line is always perpendicular to its axis. So if you are keeping the Maddox rod horizontally, something like this, the person will see a vertical line. Person will see a vertical line, while if we keep the Maddox rod vertically, so here person is seeing a vertical line like this, while if I am keeping it vertically, the person will see the horizontal line, right? So if the patient is he is holding the Maddox rod horizontally, we will see a vertical line, and if the patient is holding the Maddox rod something like this vertically, then he will see a horizontal line. Okay. Now what we have done, suppose I am suspecting a patient that he is having the exophoria or esophoria, he is having the squint. Okay. Now because the patient, we are suspecting that he is having a horizontal squint, we are keeping it horizontally. Means you have to always keep the Maddox rod parallel to the axis of deviation, parallel to the axis of the squint. So if I am suspecting horizontal squint, I will keep it horizontally and the patient will see a vertical line. If I am suspecting a vertical squint, I will keep it vertically and then the patient will see a horizontal line. Okay. Now suppose this patient comes to us and we are suspecting some horizontal squint, either esophoria or the exophoria. Like here we have been given the question having exophoria. So we have kept this Maddox rod with the cylinders parallel to each other, and therefore he is seeing a vertical line. So suppose this is the right eye and this is the left eye. So now left eye will see a vertical line, something like this. Okay, left eye will see a vertical line because we have kept the Maddox rod, and the right eye is seeing a dot because we have not kept the Maddox rod. So we have asked the patient to hold the Maddox rod in front of one eye, and now we ask the patient to see at a light. Now when he is seeing at a light, the eye which is having the Maddox rod, that eye will see a line like this, while the other eye that is not having that Maddox rod will see a dot reflex. So by doing this, what I have done, I have actually created the dissimilar images. Both the eyes are not seeing similar images. And fusion occurs only in cases of similar images. So what we have done, we have actually broken the fusion. In the latent squint, what happens? Squint remains hidden due to the fusion. So in order to diagnose, in order to detect this squint, I have to break the fusion. Now for breaking the fusion, I can either stop this simultaneous perception. I can stop the simultaneous perception by cover-uncover test, or the other method is by creating the dissimilar images, and dissimilar images can be created with the help of this Maddox rod test. So what is happening if the person was not having the squint? Suppose I say the person is not having the squint and one eye is having the Maddox rod, one eye is not having the Maddox rod. So one eye is seeing a dot reflex and one eye is seeing this line. There can be simultaneous perception. So the person will see both the light reflex as well as a line in the similar plane. Suppose this is the plane here. So he will see this dot reflex as well as the line in the same plane. So if the person is seeing like this, then I can say that the person is orthophoric, or there is orthophoria because simultaneous perception is present. But suppose there is squint. So there is no alignment of the two eyes. So now there will be diplopia. Both the eyes are seeing both the images separately. So there will be diplopia. Now another important thing is that diplopia can be of two types. It can be a cross diplopia or it can be uncrossed diplopia. Now cross diplopia is found in the exo squint. Why? That is divergent squint. This is found in the divergent squint, while uncrossed is found in ESO, that is your convergent squint. Now, try to understand why there is crossed or uncrossed diplopia. Suppose I say that the person is having divergent squint. Divergent squint means something like this. See this. This eye is diverging like here and this eye is diverging towards this side, right? So what is happening? They are focusing, they are projecting the rays on the temporal retina. Suppose I say this is the eye and the patient is having the exo. Okay, so this eye has gone outside towards the right side and this eye also gone outside towards the left side. Alright, so this will be projecting the rays on the temporal retina of the right side and this is projecting the rays to the temporal retina of the left side. Yes or no? Because this has gone outside here and this has gone outside here. So what is happening? Now temporal retina, suppose this here, temporal retina casts the image on the nasal side. See here. So this will cast the image here, while this retina will cast the image again on the nasal side. So this here. See, both the images are become crossed now. My hands have crossed now. So similarly, you can see it here also. This temporal retina will cast the image on the nasal side. So image of the right eye here, while this temporal retina will cast the image on the nasal side, nasal field here. So image of the left eye formed here. So there is crossing of the images. This is called as cross diplopia. Hear it one more time. Both the eyes have deviated outside. So this eye deviated outside, this eye deviated outside. So when it is deviated outside, which part of the retina they are using to form the images? It is the temporal side. Temporal hemiretina of this eye and temporal hemiretina of this side. Temporal retina of this side will form the image on the nasal side. So here, and temporal retina of this eye will form the image on the nasal side here. So there will be crossing of the images, right? While in cases of convergent squint. Now try to look when the patient is having convergent squint. Now, patient is having the convergent squint, suppose something like this. So this eye deviated inward here and this eye deviated inward here. Something like this. So what is happening? Now they are projecting the image on the nasal retina. Nasal retina of the right eye here and the nasal retina of the left eye here. Something like this, right? Now nasal retina will form the image on the temporal side. So their image of the right eye is formed here and the image of the left eye is formed here. So there is no crossing over. Similarly, look at here. This eye deviated inward here. This eye deviated inward here. So they are using which fibers of the retina? The nasal fibers. So images are formed on the temporal field here. So this image will be seen here and this image is seen here. So there is no crossing over of the images. This is called as crossed and uncrossed diplopia. Okay, so crossed is found in the divergent squint and uncrossed is found in the convergent squint. Okay, now based on this, we'll try to solve the question that is given here. Now see here. They are saying that a person comes to us with the left eye exophoria. So we'll try to draw here. This person is having the left eye exophoria. Something like this. So suppose these are the eyes, okay, and I say this is the right eye and this is the left eye, okay, right eye and left eye, and the left eye is having the exophoria. The left eye is having the exophoria, okay. Now they are saying that we have kept the Maddox rod in front of the right eye. So we have kept the Maddox rod here, and because it is exophoria, it is the horizontal one, therefore I will keep it in the horizontal axis. So we have kept the Maddox rod with its axis parallel to the horizontal plane. Now what will happen, this eye where you have not kept, okay, you have not kept the Maddox rod, this eye will see a dot and this eye should see a line because here you have kept the Maddox rod. Okay, this is something like this. But because it is exophoria, that means it is a divergent squint, this will be seen on the opposite side. So this dot will come on the opposite side, something like this. So this person will see that this dot light reflects, which will be on the right side of this vertical line, on the right side of this vertical line. So due to this, what will become the answer? The answer will be vertical red line first of all, because we have kept the Maddox rod horizontally first of all, then with a bright red spot which is right to it, which is right because you are having the exophoria in the left eye. So ideally what is happening, we are keeping the Maddox rod in front of the right eye. So this should see a line and the left eye should see a dot, but this eye is having the divergent squint, so this will come on the opposite side like this. So now this vertical red line is there with a red spot on the right side of it. Therefore the answer is vertical red line with a bright red spot right to it. So this is how we have solved. You should know what is Maddox rod. You should be able to recognize the Maddox rod. What is the principle, how it is converting into a line, how should you keep the Maddox rod, then how it is actually helping in the detection of the squint by creating the dissimilar images. Then you should also know about crossed and uncrossed diplopia, how the crossed diplopia occurs in the divergent squint and how this uncrossed diplopia occurs in the convergent squint. Any query, any question or any doubt related to this, you can always ask me on the DBMCI Premier group. I am present 24/7 there. 2019 group, you can tag me there as Dr. Neha Agarwal, and you can also ask your doubts on the ophthalmology group. Your doubts are most welcome, and also tell me in the comment section how did you like the video, did it help you, and anything that you want me to further discuss, do let me know. Thank you and bye-bye.